Welcome! In this video, we're taking a tour of my Puppet Pin plugin for DaVinci Resolve. We'll start simple for quick results, then go deeper to break down the important features and explore more advanced workflows. You can find a download link for the plugin in the description. I've loaded an image of a guy doing a kick, and I want to tweak his pose. In the flow, I add a Puppet Pin node and connect the image to it. First thing we'll see is the Mesh tab, where a mesh has already been generated for us. In this case, it works great out of the box, covering the subject cleanly without clipping. The mesh is generated from the non-transparent pixels in our image. If we need to, we can tweak the controls to adjust how the mesh is generated. Let's head over to the Pins tab. This is where we create, place, and move pins to warp the mesh. Each pin has a source position, where it grabs vertices from, and a destination position, which is where it moves those vertices to. I'll start by creating our pins and setting their source positions. When I click Add Pin, it enables a new pin and switches us to Source Pin View so we can place it where we want. I'll add 4 pins, one on the grounded foot, one on the kicking foot, one on the hips, and one on the neck. With the source pins in place, I click Create Controls. This switches us to Destination Pin View and gives us viewer controls for each pin. Now we can grab and move them to warp the character, bend the leg, tilt the body, maybe exaggerate the kick. For simple pose adjustments, this is really all you need to do. Let's look at the other pin controls, the most important of which is the radius control. Increasing the radius lets the pin grab and lock down more vertices, as well as allowing us to use the rotation and expansion controls. There's also the Render Layer control, which controls the order the mesh triangles are rendered in. In this example, we can decide whether we want the tail in front of the body or behind it. Let's make a simple looping animation using this image and explore some of the animation features in the plugin. We'll start by placing down our pins just like before. One pin for each foot, and for the hips, and one for the neck. Next keyframe the neck pin, swaying it back and forth. This is a 30 frames per second animation. So I'm going to add 2 keyframes, one at frame 0 and one at frame 30. In the spline controls, select your keyframes and click both smooth and ping pong loop to create a smooth back and forth loop. Now, let's explore the Deformers tab. In this tab, we can create deformers, which modify the positions of pins in useful ways. There are 3 deformers currently: follower, inverse and forward, kinematic, and wave deformer. Let's select and enable the follower deformer, which lets one or several pins follow the movement of a target pin. In this case, we want the hip pin to follow the neck pin. So we select pin 4 as our target pin and type 3 as our follower pin. Adjusting the amplitude and delay creates a soft swaying motion. Finally, let's increase the pin radius on the feet pins. This locks them firmly in place, making them unaffected by other pins. And there's our simple animation. I mentioned the wave deformer, which can be used to rotate a chain of pins around a base pin or oscillate a chain of pins. Here we animated the fox's tail without any keyframing at all, just using the oscillator inside the wave deformer. The last deformer is the IK/FK deformer. This deformer is super useful for animating characters. This skeleton has been rigged up with IK deformers for the legs and FK deformers for the arms, and a follower deformer to tie it all together. In the Solver tab, we can choose between 3 different solvers and tweak their settings. Once the pins have moved their vertices, the solver takes over to adjust the remaining vertices, moving each one incrementally to restore its original local structure. The single frame solver starts fresh each frame, beginning with the base mesh and solving from there. The multi-frame solver instead uses the mesh from the previous frame as its starting point. This has the effect of smoothing the vertices as they settle into place. Lowering the iteration count sliders can increase this effect. The multi-frame solver looks pretty good. It makes the animation less stiff, but it can be hard to get perfect looping animations from. The elastic solver works similarly to the multi-frame solver, but also adds springiness to each vertex, making them wobble as they settle into place. The Locator tab lets us track the position and rotation of a single vertex or pin and output that data for use in other tools. Let's use it to add a mustache to the animated girl. We enable a locator and move the source position to her nose, then we click Build Locators. Next, we enable keyframes for both locator outputs, position and rotation. We can link those outputs to a merge node using either expressions, which we do here, or by right-clicking and using Connect To. The use for locators is pretty niche. I've mostly used it for location data in particle systems. Puppet Pin works with video input to either stabilize or reanimate the video. To set it up, mask the moving subject and turn on the Rebuild Every Frame toggle in the Mesh tab. Then use DaVinci's built-in point trackers to track points on your subject and link those points to the source positions of your pins. The Puppet Pin node has 2 optional inputs. One is a mesh mask input. When this input is connected, we use that image to build the mesh instead of the main input. Here we copied the simple animation we created before and use the same image of the girl as the mesh mask input. The base input, however, is this separately animated hair. The other optional input is a mesh weight map, which is being used here. The weight map can be used to lock down or reduce movement of vertices. Here, the knight has been locked down using the mask, and the cape has been animated using a series of wave deformers. Let's walk through how a rigged and layered animation is done by animating a walk cycle for this ostrich. Here is the finished animation we are going to create. This ostrich has been separated into 4 layers using the free image editing software, Affinity. After separation, each layer needs to have its missing cutout areas filled in. I used a combination of regular brush tools and clone stamp tools to do this. After you have your layers, you can export them as a layered.psd file, which can be imported right into DaVinci Resolve. The exported .psd file needs to be in an 8-bit color space. The way this rig is set up is using instance nodes. Instance nodes share all controls and keyframes between each other, except controls which we selectively de-instance. So first step is to create a driver puppet pin instance. This node is empty and we don't touch it at all. Next, we create 4 instance nodes from that driver node. We open up each instance and go to the Settings tab to select the ostrich layer we want to animate. Here we need to de-instance the control so that each node can have its own layer. Next, we need to merge these layers back together. We do this using a multi-merge node. Now we place our pins, 3 for each leg, 1 for the head, 1 for the body, and 1 for the tail. Next, we create some deformers. The body has a follower deformer, which targets pin 7. And each leg has an IK deformer. Now we are ready to animate. The IK deformers make animating the legs easier. If you want the feet to plant more firmly on the ground, I'd recommend separating them into their own layers. A pin only affects a mesh when it overlaps a mesh. So, for example, the feet pins don't affect the tail because they are not overlapping the tail mesh. But if the pin did overlap the tail mesh and you still don't want it to affect the tail mesh, you would go into the tail node and de-instance the destination pull control for that pin and set it to 0. To separate the tail from the body a bit, I de-instance the destination pull control on the tail and lower its value. Use follower deformers for easy secondary motions. We use 2 additional followers here, 1 for the head and 1 for the tail. Okay, that's it. If you have any questions, go ahead and ask in the comments. Subscribe for updates and more tutorials.